All right, guys. Well, happy St. Patrick's Day. I'm glad you all came to school and you're not at the parade. Now, we need to get to work because plate tectonics is just the beginning, right? Plate tectonics is an idea, is the proof. Great. But we got a bunch of work we need to get through to understand the different plate boundaries. So, with that, let's get going. So divergent plate boundaries. Some we're all in different places, so I'm going to just give a recap. Um, Divergent plate boundaries are where two plates are moving apart. Right? To diverge is to move apart. Right? So let's definitely write that off to the side. Move apart. So take a look in these diagrams. Make sure you're familiar with what you're looking at here. Key things. Right? We see the arrows over here, right? And those arrows are showing that they're separating. You're forming the rift valley up here. And rifting, right? Rifting now we see happening over here. That's the actual separating of plates. Now as the plates move apart, there's less pressure. When there's less pressure, that allows for more melting, and that's why you see the magma then come in behind. Right? There that sequence is going to be really, really important. Right? Plates pull apart, decreased pressure. The decreased pressure causes the formation of the magma, and then as the magma comes up, now we have the mid-ocean ridge. So seafloor spreading, the other important word there is mid-ocean ridge, because that's going to result from the seafloor spreading. You're going to get the magma that's going to pool up. We're going to hit that high center in the middle of the ocean. Keeping with this theme, right? Divergence is the pulling apart. So there's tensional stress, and tensional stress, think like a guitar string, right? When a guitar player wants to tighten up the strings to change the pitch, they're going to turn and you put more and more tension in those strings or those wires basically, and that's where we get the doon 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 doon. Right? The pitch keeps going up higher and higher. And that's because the stress is tension. Right? So we're pulling is tension, and tension is a form of stress. Now, if you pull too much, you might actually cause the rocks to break, or the crust to break, and that's when we find a normal fault. So this is where it's going to get a little complicated. Right? I said we had a lot to get through. Right? So tensional stress leads to a normal fault. Now, classic drawing of a normal fault, you're going to have a hanging wall, and you're going to have a foot wall. Now the foot wall stays stationary while the hanging wall moves down in relation to the foot wall. So it broke, right, because you had tensional stress, and then after it broke, it slid down. So that's what we're seeing down here with the hanging wall and foot wall. On a test, definite diagram type thing for you guys to match up. Just a reminder, right? You have that test on Thursday, and diagrams that are going to be important, right? Diagrams to remember would be your plate boundaries, which are going to be a big focus right now. Oh boy. You're going to need to know the layers of Earth. And now we're actually seeing faults, which is going to be a big topic. So take a little time. Try to digest these things, and you can be all right. So again, hanging wall drops down. That makes a normal fault. So what happens next at a divergent, right? So first it pulls apart. You get those normal faults, which actually you're seeing here. You got a normal fault right here, and you got a normal fault right here. That creates the downdrop block, lowers the pressure, and boom, we start getting the magma coming up. That sets up for seafloor spreading. So rifting, Rift Valley, seafloor spreading, mid-ocean ridge. All right, I think I said that enough times. Important things here. The divergent boundary is a constructive plate boundary, meaning that we're making new seafloor, right? To construct, to make something new. Outside, they're building a new building. That's construction, right? Destruction is when we break things down, and we'll talk about that later. So plates move apart, seafloor spreading, make new ocean floor. Important part, and this again could be a little confusing, but divergence is to divide, is to separate, to pull things apart. And I don't want you to think divergent you're destroying. No, dividing, and you're allowing for new crust to form. All right. Again, same words over and over again. Mid-ocean ridge, Rift Valley, seafloor spreading. One note, since it's over here, Iceland is one of the few places where the mid-ocean ridge system is above sea level. Iceland is one of the few places that the mid-ocean ridge system is above sea level. And then we continue. So if pulling apart was divergence, pushing together is called convergence. And with convergence, there's compressional stress. Compressional stress, you're squeezing something. You're pressing it together. And now, convergence, compressional stress, pushing things together, we're either going to end up with a subduction boundary, in which case an oceanic plate will go underneath another plate, or you'll have continental plate push into continental plate, what we call a collision boundary, and that collision boundary is going to build mountains. So again, the stress that we're talking about here is compression. It's a squeezing. We're going to make things thicker. Now, if we squeeze them together, well, we can actually reverse the process that we saw before. So tensional stress, we got the normal fault. This is when we're going to make a reverse fault. So here you can see the hanging wall moves up in relation to the footwall. And you guys can see right over here, the hanging wall moving up. Right. This is the hanging wall, and now it sits above the footwall. All right, again, good diagram. But let's take a look here. We see an oceanic to continental convergence, and this makes a subduction in the first one, the Nazca plate subducting underneath the South American plate, and you get volcanoes on the overriding plate. Then you have the oceanic Pacific plate subducting underneath the Laurasian plate, and here you're going to get, again, volcanoes on the overriding plate. Anytime there's subduction, you got volcanoes on the overriding plate. But where the Indian plate smashes into the Eurasian plate, this is a convergent boundary, and that's where you're forming the Himalayas. So again, just to put some words down, we have a subduction this is another subduction, so let's put oceanic to continental subduction. This is going to be oceanic to oceanic subduction. And then down here we're going to have continental to continental subduction. These are all, again, types of convergent boundaries. All right. So this gives it a little more detail. Oceanic plate colliding with a less dense continental plate. And let's just highlight then that the oceanic plate is where the subduction is going to be. Right, the oceanic plate subducts. And why? Because oceanic plates are more dense than continental plates. They're younger, but they're more dense. Right? Remember, 3.3 grams per centimeter cubed versus continental plate 2.7 grams per centimeter cubed. Right? So the less dense continental crust never subducts. Then you got your subduction zone showing you here the volcano on the overriding plate. So subduction, slab pull is the mechanism. Slab pull is the mechanism right there. We'll try this green. All right, slab pull is the mechanism for plate tectonics, and then you have the volcano on the overriding plate. This, by the way, is actually, since it's continental, this is called a volcanic mountain chain or mountain range. You also then have your deep sea trench. What I'm going to shorthand right here is the DST, deep sea trench, and that's actually right here. So every time you get subduction, you're going to have that deep sea trench. Oceanic to continental, again, volcanoes on the overriding plate, still going to have the deep sea trench. This diagram I really like. It's a good one to sketch out, right? Because it's showing you the volcano on the overriding plate. It's showing you the oceanic crust against the continental crust. The other part I don't like is the way they call lithosphere there, because we should remember that lithosphere is the crust plus the uppermost mantle. Okay, again, emphasizing the volcano on the overriding plate. There's a lot of repetition here. A lot of repetition. Got your Andes Mountains. Right, and then you got oceanic to oceanic. So oceanic to oceanic, the denser plate will subduct. Right, the older, so right here I'm going to say older, denser. Right, because they're both oceanic plate right here. But again, volcano on the overriding plate. Now this is going to actually make the volcanic island arc. The volcanic island arc is what the Aleutian Islands are. All right. If you've noticed here, you're getting a lot of different views of these diagrams. Any one of them would make a great diagram for a test or quiz. Remember, test Thursday, quiz Tuesday, and then we'll probably review the rest of Tuesday. Cool. All right. So then, continental to continental, this is called a collision boundary, and this is going to result in mountain building. So no volcanoes this time, right? Collision, you either get volcanoes with the subduction, or you get collision and you get mountain building. So again, we're pushing these rocks together. There's squeezing, compression, but we're going to suture them, and we're going to end up with a big old mountain. All right, so you got a bunch of different ways to see this. All right. As the oceanic plate subducts, eventually the other side's going to have continent. And so when that ocean closes, over here, then you end up with continent to continent. And continent to continent can't subduct because it's less dense than the asthenosphere. And so we're going to suture together, we're going to make a new mountain range. That's the key point here. Again, ocean closing. And here you see the Indian plate sutured, right? Sutured right over here. And now you get one big plate. And you also make some mountains. All right. So some helpful connections here, helpful hints. Convergent, connecting boundary. All right, and basically you squeeze and compress things together. Your transform boundary is when two plates slide past one another. So the most famous version or example of this is the San Andreas Fault in the United States. That's our big example. But there's offset. Right? You build up stress in the rocks, and then it overcomes that friction, and you get plates that are going to slide past one another. They're not pulling apart like divergent, and they're not pressing into one another like convergent. Instead, they're sliding past one another. So when I think strike slip, I actually think like a pair of scissors. The way that scissors actually slide past one another in order to cut through something. And it's classic to see the arrows going in the opposite direction. But big thing here is you're in the horizontal plane. Right? When I think horizontal plane, I'm going to later think back to this as a strike slip fault when we talk about individual faults. But for right now, just think shear stress, like a pair of scissors. Right? Back in the day, they used to call them shears. All right. So your San Andreas, as I said before, it's a long transform fault along much of the west coast of the United States. It's a nice little picture. We do, by the way, have transform faults all along the mid-ocean ridge. It actually offsets the mid-ocean ridge, which is kind of cool. All right, so again, shears like scissors. And then plates slide horizontally past each other. And this has to do very much in this slide with the mid-ocean ridge and making the connection to how the plates could move about on Earth's surface, even though the Earth's surface is round. That's because when we have plates that are trying to slide, you get these transform faults that allow it to slide along in increments. All right, guys. So we're going to stop there for today. I think we got some good work done. And we will pick up on Monday. Right now, there is an activity sheet or worksheet for you guys to do for homework. But go ahead and get started. And I'll see you guys on Monday. Again, happy St. Patrick's Day.